All right, problem number 21. So we have this model. It's used to find yield, and it says this is equal to some positive number k times n divided by 1 plus n squared, where k is greater than 0. And it asks what nitrogen level gives the best yield. And the idea here is this isn't actually an optimization problem in the terms of like 3.7. This is just a normal 3.1 style. I only have one variable because k is just a number. Doesn't depend on anything. So what I'm going to do is I'm going to take a derivative. So y prime is equal to low times the derivative of the high, which is k, plus the top times the derivative of the bottom, which is 2n. Divide that all by 1 plus n squared squared. And again, this is that idea. I didn't need a constraint function here because everything's in terms of one number. So I get k plus kn squared. This plus here that I wrote should have been a minus because this is quotient rule. Minus 2kn squared over 1 plus n squared squared. So I get minus kn squared plus k over 1 plus n squared squared. Or if I factor out a k, I get 1 minus n squared over 1 plus n squared squared. So now I need to check for critical points. So where are the critical points on this guy? The denominator is defined everywhere, so that's not going to be an issue. So now we set the top equal to 0. So k times 1 minus n squared is equal to 0. And let's note something. Well, 1 minus n squared equals 0. Because k is just some number that's bigger than 0, it doesn't matter. So when is 1 minus n squared equals 0? You can solve this and get that n is equal to plus or minus 1. But we're talking about nitrogen levels in soil, right? So -1 probably wouldn't make sense, so we let n equals positive 1. And now what we do is we're going to do first derivative test. So f prime of x. Here I know that k is just some number greater than 0. So we have k 1 minus n squared. The bottom is always positive, so I'm not going to worry about that. K I just said was always bigger than 0. 1 minus n squared. If I plug in something less than 1, but really I need something positive, so something between 0 and 1, I'm going to get a positive number. If I plug in something bigger than 1, I'll get negative. So then I get plus minus. So this is a max. So what did I do here? I did do an optimization problem, but I didn't need a constraint. And this can come up, it's not likely. But it's good to have this as a skill set because maximizing things is important, and sometimes you don't need that constraint function.